In this part of the question from the Pilot 2012, we're asked to complete the table of values opposite, or in our case below, giving the values to three significant figures. Okay, so all we need to do is take the values in the top row, in this case 1427, so it's the ln of 1427, and that gives me 7.263329617, but it's asked it for three significant figures, so I'm simply going to round that to 7.26. And similarly for the next one, 4497, take the natural logarithm of that, and the three significant figures, I'm getting 8.41. And then for the bottom row, take the natural logarithm of 10.753, I'm getting 9.28. And then finally, the natural logarithm of 60,150 is the three significant figures, 11.0. That's all that's needed for part B. For part C, using the grid opposite to plot ln t against ln d. So we're plotting the second row here against the fourth row. So along the bottom here, we have ln d, up the side, we've got ln t. Now it's important to notice that there's different scales on the x-axis to the y-axis. On the x-axis here, the increments, there are 10 of them, between 0 and 1, so each increment we're going up in 0.1, whereas on the y-axis 1 would be halfway there. Actually the scale is half, so actually we're going up in increments of 0.2. So be ever so careful how you plot these, and you should end up with some points looking a bit like this. The last thing to do then, draw a line of best fit. Now when you draw your line of best fit, make sure you use a ruler, go through all of the points, and then I'd extend your line right down to here so we can find the y-intercept, because that could be useful later on. Having linearized the equation, chances are the equations later on going to use that y-intercept to find one of the constants. And that's all that's required for this part of the question.